Hi, good afternoon, students. So, this is going to be a lecture on DFS and BFS, and also we will discuss the code part of DFS and BFS, and also we will discuss introduction on hashing and the two methods of hashing for the exam related part. Right. So, let's go to the PPT first. Now, in this PPT, we have discussed in the class what is a graph and what are the components of it. The graph components consist of vertices, which are called as nodes, and edges. Okay. We have also discussed what is the adjacency matrix. Adjacency matrix of INJ is 1 if there is a connection between two nodes, 0 if there is no connection between two nodes. You draw a matrix for all the nodes, right? And you're going to compare every node, right? You're going to compare V1 with V1, check if there is any edge between them. So there is no edge between V1 and V1, so you put 0. You check for V1 and V2, you see that there is a connection between V1 and V2. So what you're going to do, you put a 1. Like that, you check for V3, V4, V5, and V6, all of the nodes. That completes our first edge V1, or first vertex V1. Now the same way you're going to check for remaining nodes. You're going to check for V2 and you compare V2 with V1, right? You're going to compare V2 with V1. There is a connection, you put a 1, right? Now check for the next one, V2 with V2. There is no connection between V2 and V2, you put a 0. Next you check for V2 and V3. There is a connection between them, you put a 1. Next V2 to V4. There is a connection, you put a 1. Next V2 to V5. There is no connection, so you put what? You put 0. And also the same way, you put 0 for V6. Like that you keep on continuing for all the edges, for all the vertices, right? That gives you the adjacency matrix. We have already discussed this in our class. Like that, the same way you're going to take the adjacency list also. What is adjacency list? Given a graph, what node it is connected to? V1. V1 is connected to V2. What about V2? V2 is connected to V3, right? V4 and also V1. Why it is connected to V1? Because this is a undirected graph. Since this is an undirected graph, right, we can check for the all the combinations or whatever the edge it is connected to. Okay. Now, let's take the example of V4. What about V4? V4 is connected to V2, V3, right, and V6 and V5. Like that, we are going to take what? We are going to take the adjacency list. We have already discussed what is BFS and DFS in our class, and also we have given an example of how do you find a friend in city if you use the BFS and DFS. As an example, I have given this graph and I have asked you what is the BFS and DFS of this. Many of you has given the correct answer. The BFS, since this is a level wise, right? Since this is level wise, the BFS of this will be 1, 2, 3, 4, 5 and 6, right? 1, 2, 1, 2, 3, 4, 5 and 6. What about DF? DFS is depth wise. You check for 1, next you go to the next one, depth of 2, right? Is 4. Now you're going to do what? You're going to do something called as a backtrack. Check for the nodes which are to the right. There is no right node, so backtrack again, go to the root, and now we go for the right side. 3, 5 and 6. This is BFS and DFS. Now let us see the code part of this one. Okay, let me open it. What is the adjustment in the list? Now given this is 0 and this is 1 and this is 2. Right? Now I want to find the adjacency of this graph. You know that adjacency has a matrix and also it has an edge list. What am I saying about edge list? What the node is connected to. So 0 is connected to 1 and 2. Right? What about 1? 1 is connected to, since this is an undirected graph. Since this is a undirected graph, we can also say 1 is connected to 0. What about 2? 2 is connected to what? 2 is connected to 0. 0, 1, right? 2, have 3 here, right? We have 4, right? And 4 is also connected to 3. Now, suppose we have a graph like this. Now, if I want to find the adjacency list of 1, right? What will be the adjacency list of 1? Since this is an undirected graph, I'm going to get 0, I'm going to get 2, I'm going to get 3. What about 4? 4 is connected to 0 and it's also connected to 3. Whatever you have seen here is called as a adjacency list. So given any graph to perform the BFS and DFS, so in this code, we need to draw the graph, right? And we give the key value pairs. Since this is a dictionary, right? This is a dictionary. We need to give a key value pairs. What is the key and what is the values? Understood on this one, first one? Now let's see the BFS and the DFS of these two. Right, so let me erase this. Let me draw the graph. 0. 0 is connected to what? 1 and it is connected to 2. Okay. Now let us see 1. 1 is connected to 0. 1 is connected to 0, but it's also connected to 3. So we draw one more graph. 3. One more node 3. Check for the second 2. 2 is connected to 0, but it is also connected to 3. It is also connected to 3. Now check for 3. 3 is connected to 1 and 3 is connected to 2. So 3 is connected to 1 and 2. So we're talking about this graph. What is the BFS of this graph? What is the BFS of this graph? It's going to be 0, 1, 2 and 3. What about DFS? 0, 1, 3 and 2.